Yeah, shall I start?
Yes, sir. Yes, sir.
Yeah, I would first of all let us thank S. Vidhunandanan from AFS School, Bangalore. He was kind enough to connect all of us, so he is kind of a platform here. And I wish to introduce Vidhunandanan. Hmm? Vidhunandanan S. He was born 12th August 2009, and he stayed at a place called Unapuda in Kolattur, Malappuram district, Kerala. He is 14 years old now, and he is a fan of theoretical physics. He likes to read a lot. It's a mysterious joy while joining, reading through the words of Stephen Hawking, Carl Sagan, etc. The mix of science with literature gives literal goosebumps, he says. The insights we get through scientific books are somewhat better than podcasts or videos, of course, because there is a personal touch out there. Along the reading, he spends time doing different puzzles, Rubik's Cube, Megamix, 3x3, 4x4, and solving these gives him a special satisfaction. And of course, he uses quality time for writing too. He writes blogs and Facebooks, etc. Like he said, like a wise man said, when one writes, he projects his soul into the paper. Writing somehow helps him to come up with unique perspectives about the concepts and theories that he reads. Some of his achievements are interesting. The winner of the Akash Mitra Award 2024 award given to students to reach in astrophysics. So he does research in astrophysics. He is the state level winner of multimedia presentation selected for UVIKA, YUVIKA of ISRO in 2024, and day after tomorrow he will be leaving for that program for the next 12 days. He is an author of a book called The Eternal Symphony of the Cosmos, which he will introduce us briefly as we go along. And I think with this wonderful introduction, I'll leave the stage to him. He's going to talk to us on a great topic called the origin or the genesis of the cosmos and the scientific interpretation of God. Yes. Yeah. I welcome Sarita Joshi. Yeah. From Memphis. Yeah. Yeah. Over to Vidhu.
Sir, can I just share my screen here?
Yes.
Sir,
Yes.
I can't share my screen here.
Yeah, just a minute. I'm giving permission.
Okay.
Yes, you can do that.
Good morning, everyone. So today I am going to speak about two topics: the genesis of the universe, how our universe came into existence, how all we see around, the matter, books, these laptops, mobile phones, us, trees, buildings, earth, planets, sun, everything came into existence within everything came into existence with an explosion, they say. The scientists say everything came into existence with an explosion, and that is what we call the Big Bang. And the other subject is the concept of God, the science behind the concept of God. We all go to temples or mosques or churches, etc. But we never care to understand the science behind the concept of God. How do we came to believe the God? Actually, Carl Sagan said that taking a story, making a story, and letting it live for decades doesn't make it true, right? For a story to be true, we need scientifically accurate proof. And is the scientifically accurate proof for God? Let's find out in today's sessions. I named today's session The Enigma, a journey through the vast cosmos. And like I said, we will be going through some topics. First one is the genesis of the universe, and the second one is the science behind the concept of God, or as I named it, gazing up at the divine. Okay, there are some basic things we should know before jumping into these subjects. These are the most basic things we should understand before learning these subjects. First one is a romantic relationship between time and light. As the heading says, time and light have an unbreakable romantic relationship. But what is the speed of your car? It is 60 kilometer per hour or 80 kilometers per hour, but the speed of light, it is pretty different. The speed of light is 3,300,000 kilometers per second, and there is a unit of distance based on that. Have you guys ever heard the term light year? Light year actually refers to a unit of distance. This unit of distance means the distance that a ray of light travels within an year. It has a complete year to travel, and it only reaches, let's say, half or 1 by 4 of our solar system. The speed of light might be so fast to us, but based on the large scale of the cosmos, large scale of the universe, the speed of the light is pretty low. And there is a special relation between time and the speed of light. As it says in the general theory of relativity and special theory of relativity, time and light have a relationship. When we travel at, let's say, 99.9999 percentage the speed of light, time will start to slow down. Actually, it is a rule. When you travel at the so fast through space, you travel so slowly through time. And when you travel slowly through space, you travel fastly through time. And that is where our friend light comes up. When we travel at 99.9999 percentage the speed of light, time will start to slow down. And when we reach the speed of light, 100% the speed of light, time will freeze. Time will stop for us. And when we travel faster than the speed of light, more than the speed of light, time will start to run backwards. And that is how time travel is represented in movies and books. When we travel faster than the speed of light, time starts to run backwards. And when time starts to run backwards, we get to go to the past. But it is actually impossible to travel at the 99% speed of the light. It is impossible. We have made aeroplanes, we have made vehicles that can travel at the speed of sound, not at the speed of light. It is nearly impossible to travel at the speed of light because the speed is enormous, 300,000 kilometers per second. And even as light has this enormous speed, it takes 4 years for light to reach the nearest star to us, other than sun, the nearest star to us. And that is the other funny relation here. When you look up at the sky, you see sun. But that sun is in the past. It is the sun 8 minutes ago. We currently see the sun, how the sun it's been 8 minutes ago. If you want to see the sun as how it is now, you have to wait 8 minutes later because it takes 8 minutes for light to travel from the sun to us. These are just some basic things we need to know before we go into this subject. And our first subject, the Big Bang Theory, genesis of the universe, how our universe came into existence. Our whole universe was concentrated into a small point. And when NASA launched the Hubble Space Telescope, it discovered that the universe is expanding. Galaxies, stars, planets, they are moving away from us. it is expanding more than the speed of light. That's the problem. It's expanding so fastly. We can never get there. It's expanding so fastly. So they calculated, the scientists calculated, if the universe is expanding as time is going forward, imagine what if time run backwards. If time ran backwards, the universe will start to shrink and shrink and shrink and shrink, and it will shrink to an infinitesimal point, a very small point, a quantum point. And that point is from where our universe began. The inflation, the expansion of our universe began from that single point. From that single point, it's been 14 billion years since expansion started, and there were only some particles, not even atoms were formed. It is so hot in the early universe, not even atoms could form. Particles were jiggling there and there. Particles were in a mode of chaos. There is no good temperature for atoms to form. And when atoms did form, photons, you know about light. Light is photons. Photons are particles. Photons are bosons. These particles are the, let's say, the medium. For photons are what makes up light. When light goes from this place to another, how does it go? Does it walk there? Does it fly there? Actually, light is a wave. Like we can consider light as a wave. And we can also consider light as particles, and that particles is what we call photons. Photons are the particles which consists light. So these photons, this light, can now travel around freely because all the clumped up chaos of particles has now uniformly joined to form atoms. So now these photons can freely travel everywhere. So when it travels and travels and travels, it reaches us. That photons reaches us, and what we call that photons is the cosmic microwave background radiation, CMBR. Those photons is what we call the cosmic microwave background radiation. And when we talk about the genesis of the universe, the Big Bang Theory, there are some mysteries we face, there are some problems we face. We couldn't solve these mysteries. So let's look at the mystery number one, quantum gravity. When our universe started to expand, there are places in our universe, there are mysterious places in our universe, unlike ours. Ours, we see around, there is matter, there is plants, there is life, there is us, and everything. So Einstein came up with the general theory of relativity to explain us, explain our sun, our earth, our solar system, our galaxy, etc. But we need something more intense to explain some places, some strange places in our universe, where it is populated by quantum objects which follow counterintuitive and probabilistic rules. So weird counterintuitive and probabilistic rules. We need a new special type of science, and we call that the quantum mechanics. We need quantum mechanics to explain such places, but it has been so hard for us to unify. It has been so hard for us to combine the general theory of relativity, which explains us, our sun, our galaxy, our solar system, and quantum mechanics, which explains things at a quantum level, at a microscopic level. That's the problem. We don't have a theory for that. We don't have a quantum theory of gravity, which explains gravity in quantum places, gravity in such strange places. We don't have a such theory to explain. That's mystery number one. Now, mystery number two. Our universe is too big. Let's say. It has been 14 billion years since Big Bang. So since it has been 14 billion years, like I said earlier, since it's been 14 billion years, when our universe started expanding, it should expand 14 billion light years, because that's how long light can travel. Since it's been 14 billion years, It can travel 14 billion light years. That is the limitation of light. But when we look at our sky, when scientists look up the sky, they calculated. Our universe
Raman,
is.
just check what happened. There is audio.
Sir, is it audible?
Yes, it's audible. It's audible.
Okay.
Yes, go ahead. Go ahead.
Should I continue?
Yes, please. Yes, please.
Okay. So it's been 14 billion years since Big Bang, and our universe should be bigger only 14 billion light years. But it is bigger than that. It is bigger than 14 billion light years. So now it is our limitation. We can only see the stars and galaxies 14 billion light years away. Let's say there are stars away from 14 billion years, and the light from them will never reach us, because as their light is traveling to us, the universe is expanding more than that speed. So that light will never reach us, so we can never see it. So these 14 billion light year, this area which we can observe, is what we call the observable universe. I think most of you people have heard it. The observable universe. It's what we call the universe we can see, we can observe, we can study. And there is a universe outside that, which we cannot observe, we cannot see, we cannot study it. That is mystery number 2. The universe is too bigger than it should be. And mystery number 3. The universe is too smooth. To make it easy, let me come up with a simple analogy. Have you guys ever baked a pastry or anything? And when we eat a pastry, the side of the pastries will be less hot and the center of the pastry will be more hot, right? When we bake it, the sides will be less hot and the center will be more hot. So let's say we should stand inside that pastry, inside the center, and we take temperatures from both of our sides, from our left and from our right. And when we stand it inside the pastry. So since we are at the center of the pastry, the temperature will be same. From this side and from this side, the temperature will be same. But when we stand at the side, the our direction, our side closer to the center will be more hot, and our side closer to the side will be less hot. It will be less hot. That's how our universe also works. When we take temperature from both of sides of the earth, we get same temperature. That's another problem. The photons, the cosmic microwave background radiation, the photon that started their journey from the Big Bang, travels all the way around our universe, and it comes from every direction. The temperature of photons that come in from every direction is the same. They're all the same. So how can it have time to mix it up and equalize the temperature? It doesn't have time to mix it up and equalize the temperature everywhere. When we take temperatures from both of the sides, we take the temperature of the photons coming from both of the sides. So how can photons with same temperature and same energy come from opposite edges of the universe? It is impossible unless they communicate faster than the speed of light, which is impossible, like I said. That is our mystery number 3. Our universe is too smooth for this to happen. The CMB, the cosmic microwave background, is very smooth. That is our mystery number 3. There are a lot of problems we face when we come up with the theory of Big Bang. Our genesis of our universe is still a mystery to humans. Actually, it's a great philosophy, of course. Our time, the lifetime of us, when we live, we die, our lifetime is just a blink of an eye in the large scale of the cosmos. We can hope that our descendants might crack these mysteries and give us the knowledge that we never can dream of. And that is what I was going to tell you. This is what I have to tell you. about the genesis of the universe. Now let's move on with the science behind the concept of God. So, should we put the doubt session now or at last of the class?
Yes, last of the classes could be better. 1 more 5 minutes you
Okay.
can continue.
Okay. Now, let's talk about the science behind the concept of God. All of us worship God, most of us worship God, but we never care to understand the science behind it. There is a simple science behind it. Actually, this theory was proposed by Stephen Hawking in one of his book, Brief History of Time. Then it was published in a lot of papers, and one of his other book, Brief Answers to the Big Questions. And in that book is a chapter called Is There a God? A direct question. Is there a God? He answers it with this theory. This theory has three stages. Let's look at the first stage. Like I said, during Big Bang, matter and antimatter were created. We are matter. We consider ourselves as matter, the positive energy created during the Big Bang. But let me explain it using a simple analogy. Let's say a man just dig up a hole in earth to make a hill. So what he did, he also made a hill and he also made a giant hole, that same hill-sized hole on earth. And a halfly open door is also a halfly closed door. So that is an analogy there. When matter was created, there also has been a creation of antimatter in equal amount. They both were created in equal amounts, matter and antimatter. Positive energy and negative energy were created in equal amounts during the Big Bang. We actually don't know where the antimatter is. There is an apparent asymmetry between matter and antimatter. We do not know where the antimatter is in our universe. But get this, matter and antimatter were created in equal amounts. And what do we know about opposite energies in equal amounts? Let's say positive energy and negative energy in equal amounts. What is plus 5 plus minus 5? It's 0, right? Plus 5 plus minus 5 is 0. So when we add up the matter and antimatter, the positive energy and negative energy in equal amounts, we will get 0. Our universe clearly adds up to nothing. Our whole universe, including matter and antimatter, adds up to nothing. Stephen Hawking asked a question here. If our universe adds up to nothing, then why do we need a keeper at all? The most basic concept of every religion is that the creator himself is the keeper, right? The keeper of the universe that we pray to every day. So, if our universe adds up to nothing, then why do we need a creator? Why do we need a keeper at all? And that is the first part of his argument, which explains the role of a keeper in the universe. His second part explains the role of a creator, not a keeper, the creator. The point our universe was concentrated into. Our whole universe was concentrated into a point before the Big Bang, like I explained. And that point was a quantum point, like I said. And the things in a quantum point is pretty different than it is here. What do we need to make a tea? We need fire, we need tea leaves, we need milk, we need water. But in a quantum point, all of this can, let's say, happen automatically. It says right there in his book that we can just conjure a cup of tea. That is how it works in a quantum point. It says right there in his book. So, when it can all happen automatically, you don't need a creator, you don't need an external force to trigger the Big Bang. It can automatically just happen. We don't need an extra external force for it to burst or for it to happen. That is the second part of his argument. So he said that all the believers out there can argue that these quantum situations, these quantum points could have been created by a creator, but he also have an argument for that. He said that that point was not only a quantum point, it was also a singularity. A singularity just like inside black holes. And singularity in mathematics refers to a question without an answer. Let's say 1 by 0, 3 by 0. It's a singularity in mathematics. But in physics, singularity refers to a point, a quantum point, where time and space freezes. Now, that's the point, where time and space freezes. The God cannot create the universe without a main ingredient. You cannot make tea without tea leaves, right? God cannot make our universe without time, because that point was a singularity where time and space freezes. He cannot make the universe without that time. Time and space are important for a universe to happen. Without time, that expansion cannot start. So we do not have a cause for that effect. It's a paradox. For every effect, there is a cause. I will tell you how he explains it. What caused the river? Well, perhaps the rain that fell earlier in the mountains. But then what caused the rain? A good answer would be the sun that shone down on the ocean and lifted water vapor up into the sky and made clouds. Okay, so what caused the sun to shine? Well, if we look inside, we can see the process known as fusion, in which hydrogen atoms join to form helium, releasing vast quantities of energy in the process. So far, so good. Where does the hydrogen come from? Answer: the Big Bang. But here's the crucial bit. What caused the Big Bang? We don't have an answer. For every effect, there is a cause. For everything to happen, there is a reason behind it. But for Big Bang, there isn't. That is the problem. That is a paradox that we face when we talk about the Genesis, when we talk about when the concept of God comes to us. When the concept of God comes to us, we say that God is the cause of the universe, but there isn't. There isn't a cause of the universe based on science, based on mathematics, based on numbers. There may be based on the believing, based on the faith of us, but faith should be inside us. Let's say God exists, but God exists inside us. God exists inside our minds, inside our hearts, inside our brain. It doesn't inside in our reality, doesn't exist inside our reality, but it does inside in our minds. It does exist inside our brain. It does helps us to move forward. That whole concept helps us to go through life. Every hard things that we are going through, it helps us. It gives us a confidence to move on. That's what the concept of God does to us. But we cannot surely say that He have a role in our reality. Thank you. That's all I have to say. Thank you.
Yeah.
Hey, very good, very good, very good. It's
Yes.
very
Nice
opening.
view.
Hmm. I do have few comments if I may be allowed to do.
Yeah.
I
Sarita
mean,
madam, do you have any question to ask? Sarita ma'am?
well, don't call me ma'am, please. Uh, I am just like Rashmi. So whatever you call Rashmi ji, you can call me that. So I do have question about about the existence of God, right? In general, uh, whether God exists or doesn't exist, I don't want to go into that part at all. We just talked about that. I'm trying to scientifically think about it. And here is an alternate theory that pops in my mind, and I'm going to just elaborate on that one and then seek opinion on that. Okay. So we did talk about if we are going to be going at around the speed of the light, right? The time, at 99.99% of the speed of the light, the time dilation happens. At zero, the time stops. And if we go beyond that, um, the time starts going backward, right? I consider arrow of time as entropy that is being introduced. So we talk about Big Bang, right? Big Bang, again, we are limited by our understanding by photons that we see. So that's observable universe, right? Here is the question, right? Where did the Big Bang came from, right?
Yes.
Agree that hydrogen came from there. Okay, so here is what, how I, again, this is at philosophical level. There is some scientific base to it, but not necessary, and I'm going to explain that scientific base at this point. Is beyond the observable universe, it is possible for things to travel more than speed of light. Thus, by introducing negative entropy back into the system, which causes it to collapse, which is again a full of energy, and that energy comes out as spontaneous combustion as form of Big Bang. Right here, we are conserving the energy, right? We are not destroying it, we are not creating it. Expansion of universe beyond observable universe. Within the universe that you and I see, entropy increases. Beyond observable universe, it is possible to have that negative entropy introduced so that it kind of time travels backwards and goes back to a concentrated event where the time as we know it becomes zero, right? And
Yes.
there is an essential eventual combustion that happens at that point in time when the time becomes zero and the new time begins. That's the cyclical nature of time, and that's the cyclical nature of entropy conversion, conservation, not conversion, entropy conservation, right? Or energy conservation. This is how I look at it. Like, I don't need concept of God to explain that. I don't need any of those things to be explained, right? So, so and I would like opinions on this one, right? Like, I'm not saying this is the right thing. I'm just, this is again, like I said, it's a philosophical level that I'm talking about.
Ma'am, it's based
So
on
what
the
I, and also I have found one more person who has read Stephen Hawking as fun, and I really am very very proud of you for that. Because I read those when I was young, just like that. I was just absorbing those things, and that's how I started learning about astronomy, right, in general, and then cosmology. So I really see, you are doing great. You are doing way greater than I did. But the love of cosmology is something that I can see in you, that how I started out. So I really appreciate that.
Thank you. Actually, the how the concept of God fits into all of the science that we have, it's based on everyone's perspective. It's based on each one of us perspective. Based on scientists, it doesn't. Based on believers, they make other excuses. And there are people fighting in front of NASA saying that Earth is flat. So that concept, that believing is based on each other's perspective. And there is a possibility of energy conversion, negative entropy outside the observable universe, but we can only say the possibility, the probability, not for surely. We can only understand the immensity of it. We can only understand how crucial it is when we physically discover it, when we actually discover it. And since then, we can only say the probability, the possibility, and how God fits into all this. It's based on science. It is this. Like Einstein said, everything is relative. Everything is up to everyone. It is everyone's perspective. So, how God fits into all this is based on, there is one theory based on science, there is one theory based on other believers, there is other theory based on philosophers, and it's just based on every other people. That's my opinion to this reply.
No, and I completely agree with that. God is again is how
Okay.
individuals.
Can I have another next question? Praveen wants to ask a question. Praveen? Yeah.
Vidhunandanan, thank you so much for your time and appreciate all the explanation behind this. I honestly did not know a lot of things that I learned today. Thank you for that. My question is, if everything is cyclical in nature, what happens after death, and how do we connect back to, the point of universe that you're talking about? How do we make the connection? Can you elaborate on that if you can?
That is a philosophical question, right?
Well, it's an existential question as well, right? Somebody needs to know.
But actually, it's a paradox. We don't know what happens after death. It's scientifically, we don't know what happens after death, and we cannot make a decision based on an assumption. We have to prove it. We don't know what happens after death, so we cannot connect it to Big Bang or anything. We need real proof. We need clear proof to explain one theory, to make an hypothesis, to prove it, to convert it into a theory. We need strong proof. That's what we need. We don't know. We don't know what happens after death. We cannot make a theory based on assumption. So we need more data for that. It's a paradox.
Okay.
Neha has any question? Neha, she joined late. If she doesn't have, anyone else has a question?
Yeah, I have a question. Back to the concept of antimatter and matter. So, how do we know that antimatter exists and what is it? I know it's negative energy, positive energy, and cancel out. Universe is nothing. But what is antimatter? How is it negative energy?
Actually, antimatter is just the opposite of matter. Like there is an electron, there is an anti-electron. Like there is a proton, there is an anti-proton. And we know antimatter exists because we have created some of it. Have you heard about the Large Hadron Collider?
Yeah.
CERN's super collider. We can create antimatter inside that super collider, but it is so expensive. Ounce of antimatter costs more than 100 pounds of gold. It is very expensive to create antimatter, but we know it exists because we have created it. And there is problem during creation of antimatter. If there was antimatter, let's say, it cancels up because when an anti-electron meets an electron, they both, when they meet, they both explode. That process is called the annihilation. During that process, they both diminish each other, only releasing some energy. They only release some energy, nothing, etc. They only release some energy and nothing after that. When matter and antimatter meet, they release energy by explosions. And antimatter exists, we know antimatter exists because we have created some. And there is also a philosophical side.
Yes, I guess. Yes, we can continue, sir.
Sorry, can you hear me?
Yes, we can.
Actually, I was saying there is a philosophical approach to this question because a glass half full is half empty, a door half open is half closed. And like I said, there's an analogy that I said earlier. If a man digs up a hole in earth to make up a hill, he also makes a hole and a hill. So there is a philosophical approach to this. And antimatter is just this, that it is an opposite and matter counterpart of ordinary matter. Like let's say the evil twin of ordinary matter. Antimatter exists and we have created it, and when it meets its matter counterpart, they explode. They both explode through a process called annihilation. And let's say it is possible to create energy, let's say to power spaceships, to power vehicles through this concept, but it is far from our reach. But we can hope it would be possible in the future because high tech technology, we can believe it would be possible in the future. But it would be hard to store antimatter. We need a vacuum to store antimatter. When it is stored in your box, it will go kaboom.
Raman,
Yes,
Raman, you
sir.
want to ask a question?
Nothing
Venkatraman
else.
is a great teacher. He teaches physics across the curriculum. He has taught in colleges. He has come back to school because he feels that learning happens more in schools and less in colleges. That is what he thinks, and he is correct. He has come back from a college, engineering college, to a Air Force school. Thank you.
There is a question. There is a cosmic microwaves. Is it different from microwaves?
No, sometimes they come as microwaves, sometimes they come as photons. Each time they come as different. Sometimes come as electromagnetic waves, sometimes come as microwaves. Actually, we call that it's as an analogy, like a microwave. We have a pole. We actually said analogy about that pastry, right? Yeah, it's an let's say most of physicists have a fun name of naming things. Let's say the spot of Jupiter is Jupiter's red spot. But let's say the most important thing in biology, deoxyribonucleic acid. The most important thing in physics, the Big Bang. Physicists always have a funny way of naming things. It's just a funny analogy.
All right.
If I may add to that cosmic background radiation, right? What essentially is a microwave background is the extremely red shifted photon, right? Because it has taken so long. So it has gone into the microwave range of the electromagnetic spectrum. So it is still a photon. It's just not the photon that our eyes are able to interpret, right? So any form of energy that is of electromagnetic nature is originating from photon. We call it photon because that is how we see it, right? But anything that is on electromagnetic spectrum is still a wave, and that wave was originally formed, and the wave takes form when it is when you have the when it gets red shifted, it is receding away from us, and when it is blue shifted, it is coming towards us. It's the standard Doppler effect, right? So what Vidhu you said was right. Is It's photon is just red shifted to the very extreme end of the spectrum where their microwave radiation exists.
Ritu, I have a question.
Yeah.
Yes.
Rashmi has a question.
Yeah, there was a slide which you showed. It said the universe is smooth.
Yes.
I want to know exactly what you meant by that.
Actually, I said, imagine our universe as a pastry, right? Okay, don't do that. The photons coming from the Big Bang, like I said, when Big Bang happened, everything was in a chaos, like something. Particles were jiggling there and there. There wasn't space for photons to travel freely. And when our universe cooled down, atoms start to form. These particles started to clumps up. form proton, neutrons, electrons, started to clumps up to form atoms, and there came a uniform existence. So these photons have time, these photons have space to freely travel throughout the universe. But there is this paradox, and when we take these photons, when we look at these photons, they are coming from every directions around the earth. They comes from every direction around the earth, and the energy in them is the same. So if the energy in them is same, our universe don't have time to mix and equalize the temperature all over. There is only one possibility: these particles communicate faster than the speed of light, and that is one possibility, and that is a paradox. We don't know it. Scientists cannot find how that answer, how that happens. The same temperature, the photons with same temperature coming from every direction of earth, we don't know how that happens. Does that answer your question, ma'am?
Yeah, I wanted to say two things. First thing I want to say is that there is an thumbs up and there is a thumbs down. The thumbs up part is that today happens to be the Akshaya Tritiya day. Akshaya Tritiya, on this day, anything that you begin keeps on exploring like Vidhu's universe exploded, right? So this is Akshaya Tritiya, and let young people like Vidhu and others take inspiration from and keep studying the universe. The thumbs down part is Arno Penzias, who discovered the microwave background. We lost him last week in USA. In Bell Laboratories, he discovered the microwave background in 1965, and he expired last week at the age of 92. So both these issues need to be kept in mind. The Akshaya Tritiya, the positive part, and I don't know, Penzias expiring the negative part. So I think we are talking about the positive and negative energies of the universe, kind of. I'm just taking a hint that there's nothing much about it. With this, I think we had enough of question answers. If anybody still has a question, we'll wait for a minute. If not, we'll close. Yeah.
Any question? Yeah. Um, you said in a quantum world you can conjure a coffee cup. Is that what you said? I just want to recheck. Then that's how the Big Bang started. You can
Yes, that's a possibility.
possible theory.
Because quantum superposition, have you heard about quantum superposition?
Yeah.
Quantum superposition happens when a quantum particle, can appear in both states. Let's say a particle have a spin. A spin is a property of a particle, and until we see it, like until we observe that quantum particle, that particle exists in a state of superposition. It have both a right spin and left spin. It has particle. It has properties, both properties. It has same properties at one time. It can exist in one box at one time, and at the same time it can exist outside the box until we observe it. And there is a funny experiment. There is a funny experiment based on it, the Schrodinger's cat. And I was going to say it if we have time. Actually, if we have time, I was going to say it. I had it on the slide, but we did it, so that's why I winded up.
Okay, there's a little quantum connection here. Vidhunandanan happened to attend one of the courses we floated on quantum computing, and he patiently sit through 10 classes from 22nd April to 3rd May, except Saturday, Sunday, and he sat for 1 hour, did all the exercises we gave, and that's the quantum connection to this particular talk. I came to know when he appreciated the course, and otherwise I wouldn't have known about Vidhunandanan at all. When I read his comments on the quantum computing course that he did, I was excited and I wanted to know what this particular person is doing. Then I went back to him and asked his details, and what happened now today is the product of that thing. So there is a quantum connection out here. Okay. So with this, shall we close now? Any other question?
Can we talk
Yeah.
about the book that you have authored, Vidhu?
Yes, ma'am. It
Okay.
is called The Eternal Symphony of the Cosmos. I named it based on string theory. Like string theory says, each one of us is made of particles, atoms. Atoms is made up of particles called protons, neutrons, and electrons. And these protons and neutrons are made up of elementary particles like quarks. And when we travel deeper into these particles, string theory suggests that we can see tiny vibrating strings. And each particle is a string vibrating in a unique rhythm. And that is the inspiration behind the name, a universe with its own symphony, a universe with its own rhythm, the eternal symphony of the cosmos. This book explains each topics like antimatter, quantum mechanics, and the concept of God, time, space, dark matter, dark energy, etc., etc., through a language, a poetic language with humor and delights.
Okay. Is there a way we can buy this book?
Yes, it is available on Amazon and Flipkart in almost 28, 30 countries.
Okay. Is there an ISBN number you might want to share with us?
There is, but I want to look it up. I will share the link to Kulkarni sir.
That
So,
will be nice. That will be nice.
Amazon link I will share.
Okay. Thank you.
Thank you.
We have come to the end of the session, and first of all, let me thank Vidhunandanan for doing the effort of presentation to us. I would also like to thank Sarita Joshi from Memphis, and Praveen and Pranav and Rashmi for joining in the program. And we hope we continue to discuss like this and know more and more about the universe outside and also the universe inside of the individual, both. Okay. And let us thank Professor S.V. Raman for his support. With this, I declare it closed, and he will close it. Thank you. Yeah.
Thank you. Thank you, everybody.
Thank you, everyone. Thank you so much, Vidhanandan, to join with us.